My dear children, welcome to the mathematics class. Today we are going to discuss limits and derivatives. In this chapter, in the exercise 13.1, we have discussed the limits, the concepts of limits, and we have solved the problems also related to limit of a function at a given point. Okay, my children, I hope you understood the concepts well. Okay, my children. Now come to the exercise 13.2 concepts. In this exercise, we are going to discuss derivatives. What is meant by derivative? Okay, my children. What is meant by derivative of a function? Suppose a particle is moving. A particle is moving along a straight line. At T1, T0, let us consider this is the starting point. At T0, at T1, after 3 seconds, T1 seconds, after T2 seconds, it is reaching that layer like this. Like this is moving along this straight line. Now, if you want to know the rate of change at which the distance, the position of the body is changing at various time intervals. To find the rate of change in the position of the body with respect to various time intervals, we apply derivative concept. Okay, my children, we apply the derivative concept. Not only for this one, there are several real life situations where such a process needs to be carried out. For instance, people maintaining a reservoir need to know when will the reservoir overflow, knowing the depth of the water at several instantaneous of time. Similarly, rocket scientists need to compute the precise velocity with which the satellite needs to be shot out from the rocket, knowing the height of the rocket at various times. Similarly, financial institutions need to predict the changes in the value of a particular stock, knowing its present value. In these and many such cases, it is desirable to know how a particular parameter is changing with respect to some other parameter. The heart of the matter is derivative of a function at a given point in its domain of the definition. Okay, but children. So in all these cases, not only in mathematics, in science, in physics, in finance, in economics, in all the branches of sciences, we use the concept of derivatives. Okay, my dear children? Right. Now let us define what is meant by derivative of a function at a given point. Okay, my dear children? Okay, my dear children? Right. Come to derivative of a function. Definition of derivative of a function. Suppose f is a real valued function and a is a point in its domain of the definition. Okay, my dear children. The derivative of f at a is defined by, as extends to a, limit of f of x minus f of a whole divided by x minus a, or as h tends to 0, limit of f of a plus h minus f of a whole divided by h. These limits are said to be derivative of f at a. Okay, my children, provided this limit exists. These limits should be a finite real number. Okay, my children, limit exists means these limits should be a finite real number. Derivative of f at a is denoted by f dash of a. This is read as f dash of A. F dash of A denotes derivative of F at the point A. Okay, my dear children. Therefore, F dash of A, remember this, my dear children. Remember this point, how to read derivative of a function. F dash of A is equal to, as extends to A, limit of f of x minus f of A by x minus A, or as h tends to 0, limit of f of A plus h minus f of A whole divided by h. These limits. Okay, my children, understood? Then f is said to be differentiable. If the limit exists, then f is said to be differentiable or derivable at x is equal to A. Understood this point, my children? Right. This limit is called the derivative or differentiation of f of x at A. Understood this point, my children? Right. This definition of derivative is also called the first principle of derivative. Okay, my children? The derivative definition we have discussed. That definition is also called the first principle of derivative. There are different notations for derivative of a function. Okay, my children, there are different notations to denote derivative of a function. Sometimes f dash of x is denoted by d by dx of f of x. Okay, my children, how to read this notation? D by dx of f of x. Or if y is equal to f of x, if you take y is equal to f of x, then derivative of this function is denoted by dy by dx. Dy by dx. Okay, my children, this is a notation, my children. Don't feel this is an algebraic expression. The dd gets cancelled like this. Don't do that part. Okay, my children, in algebra we can cancel dd, cancel y by x only. But here dy by dx is a notation, a complete notation. Okay, my children, right? This referred to as derivative of f of x or derivative of y with respect to x. This is also said to be derivative of y with respect to x. Dy by dx is referred to as derivative of y with respect to x. Remember this point, my children. Derivative of y with respect to x is denoted by dy by dx. Okay, my children? Right. It is also denoted by capital letter D of f of x. Different notations, my children. Okay, my children, learn all these notations. Further, derivative of f at x is equal to a is also denoted by d by dx of f of x at x is equal to a. How do you read this notation? D by dx of f of x at x is equal to a, or df by dx at a, or even df by dx at x is equal to a. These are different notations, but in general we use this notation d by dx of f of x and dy by dx. Okay, my children, remember these two notations, my children. In general, in practice, we use these two notations. Okay, my children? Right. Come to the next point, my children. Algebra of derivative of functions. Okay, my children. Let f and g be two functions such that their derivatives are defined in a common domain. Okay, my children. These two are different functions and they are differentiable functions, derivable functions. Okay, my children. Then see these four. You should learn these 4 points, my children. D by dx of f of x plus g of x means if you want to find sum of two functions, then we have to find d by dx of f of x plus d by dx of g of x. It means we can find the derivatives of these two functions separately and we can add them. Understood this point, my children? Right. Second point, d by dx of f of x minus g of x. If you want to find derivative of difference of two functions, In that case, we have to find the derivatives of the two functions separately, and we take the difference. See here, d by dx of f of x minus d by dx of g of x. Just like distributive property, d by dx of f of x plus d by dx of g of x. Similarly, here also d by dx of f of x minus d by dx of g of x. Okay, my children, understood these 2 points, right? Come to the third point, d by dx of f of x into g of x. If you want to find product of derivative of product of two functions, you should learn this formula, my children. G of x into d by dx of f of x plus f of x into d by dx of g of x. You should learn well. This is called product rule. Okay, my children, we use this formula very frequently in exercise. Okay, my children, d by dx of f of x into g of x is equal to g of x into d by dx of f of x plus f of x into d by dx of g of x. F of x means first function, g of x means second function, is equal to second function into derivative of first function plus first function into derivative of the second function. Okay, my children, understood this point. This is called product rule. Throughout this chapter, you should learn, you should remember, product rule means this formula only. Okay, my children, understood? Right. Now come to the fourth point, d by dx of f of x by g of x. If you want to find the derivative of quotient of two functions, then we use this formula, g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. Okay, my children, I will repeat this formula, d by dx of f of x by g of x. In the numerator, f of x is there, in the denominator, g of x is there. So first we write the function which is in the denominator, g of x into d by dx of f of x means derivative of the numerator minus numerator, the function which is in the numerator, into d by dx of g of x means d by dx of the denominator. Understood this point, my children? Whole divided by g of x whole square. Whatever the function in the denominator, we have to take the square of that function. This formula is called quotient rule. Okay, my children, quotient rule means immediately you have to remember this formula. Product rule means immediately you have to remember this formula. Okay, my children, right. Come to the next point, my children. Following are some standard derivatives. You have to learn all these derivatives. Total 11 derivatives are standard derivatives. 11 derivatives are there. Okay, my children, for this course of study. See that first one, d by dx of constant, d by dx of any constant, its derivative is 0. Okay, my children, remember these points. Second, d by dx of x power n is equal to n into x power n minus 1. Okay, my children. Next, d by dx of x is equal to 1. d by dx of a power x is equal to a power x into log a base e, where a greater than 0 is not equal to 1. Okay, my children. Right. Next, d by dx of e power x is equal to e power x. If you observe the second, fourth and fifth, all the functions are in the exponential forms, but they are different. This formula is used when the base is a function in x. Remember this point, my children. Base function should be a function in x, and here exponent is a constant. N stands for a real number, some constant. Whereas here it's a reverse. Base may be any constant, and exponent is a function in x. In this case we use this formula, and in that case we use this formula. And this one, e power x, base is always e only, it is a fixed base, and exponent is some function in x. In this case we use this formula. Don't be confused, my children. 3 exponent forms are there. In finding the derivative of functions which are in exponential form, this is also in exponential form, This is also in exponential form and this is also in exponential form. But we have to use a suitable formula to find the derivative of the given function. I will repeat. We use this formula when the base should be a function in x and exponent is a constant. In that case, we use this formula. Okay, my children. Now this formula, this is also a exponential function, but here base is always some constant. A denotes some constant, and exponent is a function in x. Here exponent is a function in x. In that case, we use this formula. And the third one, this is also exponential function. Base and exponent is there, but here base is fixed e only. Always there should be e base, and exponent is a function in x. In that case, we use this formula. Okay, my children, understood the difference between these three formulae? Right. Now come to the sixth one. D by dx of log x base e is equal to 1 by x. Okay, my children. Next, we are writing the derivatives of trigonometric functions. D by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. D by dx of tan x is equal to secant square x. D by dx of cot x is equal to minus cosecant square x. D by dx of secant x is equal to secant x into tan x. And finally, 11th one, d by dx of cosecant x is equal to minus cosecant x into cot x. Okay, my dear children, you have to learn, you have to memorize all these 11 standard derivatives. Not only for this first year, my dear children, for the second year also these are very useful. These standard derivatives are very useful. Okay, my dear children, that is why learn well, memorize well. Okay, my dear children, understood? Right. Now, after completing the video, after watching the video completely, read the textbook page number 303 to 310 and 318 and 319. In the textbook, read all these pages. Then you can understand the concepts of derivative of a function. Okay, my dear children. In the next class, we discuss the sums. We discuss how to find derivative of the given functions with the help of these concepts. Okay, my dear children, understood? Right.